So right now, at this exact moment, about 432,000 miles above your head, a pretty staggering reality is unfolding. I mean, we look up every day, we see this gentle, warming glow, but the truth is, we're actually orbiting a dying star. In this explainer, we're going to trace the chronological countdown to the end of our solar system. We're looking at the exact sequence of events that will eventually consume the very world that, well, gives us the chance to even be here talking about it. You see, the sun isn't just burning like a campfire or a match you strike in the dark. No, it is a blindingly violent thermonuclear furnace. It's so chaotic, so overwhelmingly powerful, that if you could somehow stand on its surface, you'd be vaporized literally before your brain even had the chance to register the flash of light. It is the engine of our existence for sure, but it's also on this slow, totally inevitable march toward its own destruction.
And to really wrap your head around the scale of that violence, think about this number. 600 million tons. That is the exact amount of hydrogen being violently crushed into helium every single second right now. Just take a second to process that. Every time the second hand on your watch ticks, another 600 million tons of matter is squeezed so incredibly hard that it fundamentally changes.
But, it wasn't always like this. Go back 4.5 billion years and there was no sun, no Earth. Just a cold, dark, molecular cloud drifting like fog through the Milky Way. Then something disturbed it. It collapsed, started spinning, and heated up until that core hit a blistering 10 million degrees. At that temperature, atoms just smashed together and fuse. Boom! Our star ignited, and it's been burning steadily right up to present day.
Section 1. Cosmic balance. A delicate stalemate.
So, for the past 4.5 billion years, the sun has basically been locked in this incredibly precise stalemate. Picture it. On one side, you've got the immense outward pressure of nuclear fusion, constantly trying to blow the star apart. On the flip side, you have the unrelenting inward pull of gravity, trying its absolute hardest to crush it. These two forces hold each other perfectly in check. The missing mass from this massive reaction converts into pure energy, Einstein's E equals mc squared made completely real, and that becomes the light that warms your face. But here's the catch. This balance, it's not permanent. The hydrogen supply is strictly finite. It started with roughly 10 billion years worth of fuel, and we're currently 4.5 billion years into that cosmic countdown. So the tank is just past half full. And as it burns, the actual chemistry of our star is fundamentally changing from the inside out. Here's what happens. As the sun fuses hydrogen, it creates helium, which is heavier. This helium ash sinks and just kind of accumulates in the core like inert dead weight. To compensate for all that useless mass, the core actually contracts slightly. That heats it up, which in turn forces the fusion to accelerate. The end result? The sun actually gets brighter and hotter over time. Section 2. Plus 1 billion years. Boiling oceans. Now, long before the sun officially runs out of gas, this subtle, creeping brightening is going to trigger our very first apocalyptic milestone. In exactly 1 billion years, the sun will become roughly 10% more luminous than it is today. I know, 10% might not sound like a huge deal, but it is absolutely enough to push Earth's temperatures past the breaking point for liquid water. The oceans are going to evaporate, creating this suffocatingly thick atmosphere of steam. That unleashes a runaway greenhouse effect, completely transforming our vibrant blue planet into a crushing, Venus-like hellscape hot enough to melt lead. Life as we know it simply ends, all because the sun got just a tiny bit brighter. Section 3, plus 5 billion years. Rise of the red giant. Fast forward 5 billion years from today. The core exhausts nearly all of its hydrogen, and that fusion engine finally starts to sputter. As the dead core shrinks and compresses under gravity, it ignites a whole shell of hydrogen fusion around it. This dumps colossal amounts of energy outward, bloating our modest yellow dwarf into a terrifying red giant. We're talking 200 times its current diameter. Its surface actually cools down, but because of its sheer massive size, it becomes thousands of times more luminous than it is today. And as the sun swells into this ruddy monster, it is going to mercilessly swallow the inner planets. Mercury goes first, vaporized without a single trace. Venus is next, just completely consumed by a tide of stellar plasma. And then, the sun reaches for Earth. Whether we actually get swallowed whole or our orbit manages to push us just out of reach, we are going to be baked to over 2,000 degrees. The atmosphere will be completely stripped away, and the rocks themselves will literally glow. Which brings us to a profoundly sobering reality. Every monument, every fossil, every single trace of human history and every civilization that ever existed will be totally erased. The planet that sheltered Shakespeare, the dinosaurs, the very first single-celled organisms in those primordial oceans, all of it will be completely melted right back into the raw, elemental material of the cosmos.
Section 4. Helium flash. A silent detonation.
Meanwhile, deep inside the compressed core of this dying, bloated red giant, temperatures are skyrocketing toward a critical 100 million degrees. At this insane heat, something extraordinary happens. It's called the triple alpha process. 3 helium atoms crash together so violently they fuse to form carbon. This ignites what astrophysicists call a helium flash. It's an event so sudden and impossibly violent that for just a few brief minutes, the sun's core will produce more energy than our entire Milky Way galaxy. No joke.
But what's truly fascinating here is that if you were watching the sun from afar, you wouldn't even know it happened. All of that incomprehensible energy is completely absorbed by the sun's own thick outer layers. It acts as a totally silent detonation, a bomb buried so deep inside the star that the bloated surface barely even flinches. Section 5. Final exhalations. A star's last breath.
Eventually, after a period of burning that helium, the fuel runs out again. The core contracts, the outer layers expand, and the sun bloats for a second time. Violent thermal pulses will just rack the star, forcing it to violently shed its outer layers into space. These vast, expanding shells of gas, lit up by ultraviolet radiation, are what we call planetary nebulas. Kind of an ironic name, to be honest, since they have absolutely nothing to do with planets. These stunning rings of color, like the helix or the cat's eye, are literally a star's final exhalations. They're carrying atoms from the sun's core out into the void, seeding the universe for entirely new worlds.
Now, at the absolute center of that beautiful expanding cloud, all that remains is the core, a white dwarf. It's a sphere roughly the size of Earth, but get this, it still contains the immense mass of the sun. It is so unbelievably dense that a single teaspoon of this stuff would weigh 15 tons here on Earth. That's like balancing a couple of heavy elephants on a tiny spoon. For trillions of years, it will just sit there in the dark, radiating its residual white-hot heat out into space.
Section 6. The final corpse. A cold black cinder. Eventually, even that residual heat is going to dissipate. The dense core will fade from white to yellow to orange to red until finally it becomes a black dwarf. Basically, a completely dark, freezing cold cinder. An object so entirely spent that it emits no light, no heat, no radiation whatsoever. But this brings us to a really fascinating question. Why are there absolutely 0 black dwarfs anywhere in our universe today? Well, the answer perfectly illustrates the incomprehensible scale of time we're dealing with here. The universe itself is simply not old enough. The cooling process for a white dwarf takes so unimaginably long that not a single one has had time to cool completely since the Big Bang. Our sun is slowly drifting toward a final state of absolute darkness that has never actually been reached by anything anywhere in the cosmos yet. When you really sit and think about that, it makes you appreciate the warm sunlight on your face just a little bit more today, doesn't it?